Hello, Mike.
Hey, Kayo.
We have a new question.
Right.
Tough one again.
I like these types of questions because they contain very few words and the topics are so deep that we could have made like a whole series to explain these things. But let's try to give our best self in this episode.
Okay, the question is, I have been looking for a robust way to write a testable networking layer. And I'm always confused about when and when not to use singletons.
So two big topics here. First is this networking layer, testability, and then we have the singleton. The singleton is a design pattern, very popular, I guess, with all the open source libraries out there.
So should we talk about singletons first?
Okay, I have the definition, actually, of the singleton pattern from the Design Patterns book by Gamma, Johnson, Vlasidis, and Helm, the GOF book, the Gang of Four. And this is obviously very summed up, but I think it gives the gist of the whole pattern. So basically, the authors say that the design pattern, the singleton, is a way to make sure that the class has only one instance, and it provides a single point of access to it. The pattern specifies that the class should be responsible itself for keeping track of its sole instance, and it can further ensure that no other instance can be created by intercepting requests for creating new objects and provide a way to access the sole instance.
Okay, that's a lot.
Yeah.
Let's maybe put some code here and go like one by one.
Right.
So if we talk about a networking layer, let's start with a class here, API client. Okay, so imagine we have an API client here, and I can just create my client, for example. That's fine. That's a normal class. You define your type, you define the methods, then properties in here, the initializer, and that's it. Now, how can we make this a singleton?
So the key point here is that this class needs to have a single point of access, first of all.
Right, so the whole point of a singleton is to have only one instance of this class, right? To guarantee that, to enforce it.
Right.
So first of all, I shouldn't be able to just create an API client like this.
Exactly. You can't create an API client like this, but at the same time, you need to provide a way to access an API client.
So first of all, we can prevent people from creating API clients by just making the initializer private.
That's correct.
Now, the type should give you access to one.
Right.
And if you follow it by the book, we would end up with a private static instance, and that's an API client. And then we would have a static function, get instance, that returns an API client.
That's it.
And you return here the instance. Okay, so now from the outside world, we can say get instance. But in Swift, what we can do is we can just make this a static let instance because we cannot mutate it. So we don't need to have a getter. The type system already enforces this for us. So it's much simpler here. We can just say instance and boom, we have access to the shared instance, and we guarantee that you can only have one instance per application run.
That's it.
So this is a singleton.
This is a singleton. Well, as it is right now, and it doesn't do much.
So what if I make this class final then?
Right. The book, though, says you shouldn't be doing this because a singleton may be extended in the future by subclassing.
The pattern is saying that we should allow extension. For example, adding more methods to the API client by having a subclass.
Right.
Right. So we could have a class my API client that inherits from API client. And then we can add more methods to it.
Yes.
Or we can even override some behavior.
Yeah, you can override,
But you can make a case that in Swift, we can use extensions without using subclass. So we can still make this final, so we don't allow people to subclass, but we have extensions to add more behavior. We cannot override behavior, but we can still add more behavior. So it's a trade-off here. If you want to allow people to change behavior of your class, you allow subclassing. Otherwise, you just allow them to use extensions. And you can still add more behaviors by using the decorator pattern, but we don't need to get there. Let's focus here. So this looks good. That's how we would implement a singleton. You have only one instance. That's what it means. But if we go to, for example, URL session.shared, which is a type provided by Apple, And you see the documentation here for the shared instance. It says that this method provides a shared singleton session object. But the weird thing is that I can still create a URL session myself.
Yeah, with different configurations as well. This is just a convenience. But of course, this breaks the whole contract that the Gang of Four refer to in their book, right?
So what people normally call this is the singleton with capital S, right? It's the by the book implementation. And you have the lowercase singleton, which is like a convenience.
Right, okay.
In this case, you have the shared type. There is only a getter. You cannot set the shared to point to another instance, which means you still have like this unique instance per application run, but you can still create your own if you want to. You can even subclass URL session. You can do other things with it.
Yeah, and that's helpful for a plethora of subjects, I guess.
Yeah, nothing bad with that.
Yeah, exactly.
Especially if you're a library creator, you have open source projects and you want people to use your libraries, you want it to be easy to use. But you also want them to, if they want to customize those types, they can still go there and create their own. So this is the difference from the singleton with capital S and the lowercase s. Because people get confused with this, because they think that this is the implementation of the singleton pattern by the book, and it's not. And then people start asking, like, well, how can I test code that uses a singleton, for example? Well, it depends, because there's nothing wrong with having a singleton and still have testable code. So let's illustrate this with, for example, a view controller, like a login view controller. And you have a method d-tap login button. And here you want to use the API client.
Okay, to log in to a service, let's say.
Yes, the singleton API client dot instance dot login.
Right.
And you pass a login request. And you get a user back, for example.
Right.
And then you do something after you log in, like show next screen. Now, this will be hard to test. First of all, we need to have a function login. It gets a closure, for example, logged in user. And let's define here our logged in user. Now, if you want to test that the login view controller is working properly, but you don't want to make an API request in your test, you have a unit test.
Right.
How can you override this call here? How can you replace the API client with a mocked one?
To be honest, personally, I don't know any way to do that in Swift.
Probably in Object-C, you could swizzle the getter and replace it with a mock. But in this case, since you cannot subclass API client, and this is a let, you cannot do it. At least in Swift.
Yep. Sounds accurate.
But there are other choices we can make here. So I want to be able to at least subclass it, because now I can have an API in here.
Okay, I see what you're doing. So you're going to have a property injection, basically.
Yes. For example, API client dot instance. And now I don't access this directly, which means in my test, I can inject this with a mock API client, for example. That overrides this login and does something else.
Right, and you can intercept now the requests to this logging function, and you can test whatever it is that you need to test in your unit tests.
Yes.
Okay.
And then there's another thing that I see people doing as well. Nothing wrong with it, but again, it breaks the pattern. That is to make this thing settable.
That's a big no-no.
Well, I don't know. Like, I wouldn't do this if I'm exposing this to clients as a library creator. But if I'm working in a team with people, I don't think there's any problem with that.
Right. That's a big assumption right there. I understand.
So now what I can do in my test here, in this case, is to inject the instance to be a mock API client. And then I don't even need this anymore. I can just go back to what it was.
Right. So now you introduce global state for the test target.
Yes. So probably in the setup, I need to set up the mock client. And in the teardown, I need to remember to replace it back.
Yeah.
So this is not a singleton anymore. This is something else. Because it's not a singleton with capital S. It's not a singleton with lowercase s. This is just global state.
Mutable global state.
Mutable global state, yes.
It's the dark arts.
That's what it is. But people still call it singleton because of the semantics. It looks like a singleton. It has a static instance. It has a private initializer. It looks like a singleton. It quacks like a duck.
Right. No, I think that's very important what you mentioned there, the semantics. I feel that if developers see the word instance somewhere, or shared instance, or .shared, something like that, they tend to think that this is the singleton pattern, but then there's no differentiation between the singleton and mutable global state. So what is this?
Yeah, I think what you can do in this case is just to call this shared if you want to make it mutable, and what's the point of making this private?
Right, and I think that's even better because now this can go back to a let, so it's an immutable shared instance. And if you want to create new instances of this API client, well, you have the initializer now.
Exactly. So at least this global state now is contained. So this is back to lowercase s singleton, an instance that is only created once. It cannot be replaced. But you can still create your own and pass it along.
Yeah, exactly.
So that's the difference from capital S singleton, lowercase singleton, and just mutable global shared state.
Yeah.
So okay, let's fix the problems here. What this is now is just shared, but in this case, if you want to test it, you will need to have a property. And now we can use property injection to replace it during tests, so we don't make API requests.
Right.
And for example, let's say that this is a Instagram-like application. And when you log in, you go to the feed screen. So let's expand this problem a little bit. Let's say we have a feed view controller now. And on view.load, we're going to call load feed.
Okay, stands to reason.
And when you load the feed, you expect to get like loaded items. And then you update UI, for example.
Okay.
So what we would need here is also to have an API and add a new method to the API client.
Right.
Load feed with a completion, and let's say it's an array of feed items.
Right.
So we need to define our feed item here. Cool. Did you see the problem? I implemented a new feature, the feed view controller, or like a feed module, and I had to add a new method to this shared type.
Right, and then the question is, why is this a problem? You know, that's what's wrong with that?
Well, let's have a look at the diagram. So imagine you have the API client, and then you have the login, and then you have a login function, and then you have the feed, and you have load feed function. And if you implemented the followers feature, you have a load followers function. But the login doesn't care about feed or followers, and the followers doesn't care about login or feed, and the feed doesn't care about login or followers. But since this is shared, we have these different modules sharing this type in the middle, this concrete type API client. And every time I need to add a new method here, I need to recompile or redeploy all the other modules because they depend on the concrete type. So what's happening here is that we have source code dependency in this core API client layer. So if I want to reuse the login in a different context, in a different application, how can I move the login module to a separate application without bringing the API client with me?
You can't, is the answer.
Well, you can if you now move the API client to a shared module, and then you move the login and you reference it.
Right, but then you make a change and then the other modules break as well.
Yeah, if you add another module, for example, upload videos, you need to add a new method here, upload video, and you break all the other modules. You need to bump a version in this framework, and now everyone else needs to update the references, and then you start having semantic versioning issues.
Right.
But we can solve that.
Yeah, we can solve it. I would just like to say here that this modular approach is not for all apps. You know, if something is small and you don't care about that, if it's a pet project, you know, it's redundant. It's excessive. It's lost time, basically.
It's wasteful.
It's wasteful, yeah. However, if you care about modular design because of the business, because of the requirements, you should probably consider breaking these things into something much more responsible.
And I think we are trading off convenience with what we really need. What this class needs is just to call a function.
Right.
But now this class actually needs to know where to find its instance, know its concrete type, and then invoke a function.
Right.
There are 3 layers here where you should need one.
And it creates this implicit dependency of this API client as well.
Yes, this global shared state here is very convenient.
Yeah.
It's easy to create and to use, but introduce some problems. So what we're doing here is making a case that if you need to achieve some kind of reusability, you might need to think about these problems. You might start just for convenience of accessing this type, but you need to understand the trade-offs. So when this trade-off bites you, you know what to do about it.
Absolutely. Absolutely.
So a solution to this problem of every time you add a new method, you might break other modules, it's actually fairly simple initially, right? Because this problem is not going to come in one hit. Normally your app starts growing and then you need to start abstracting things as you need to. And it normally happens in phases. You start with this shared implementation. And when it's time to, for example, get the login and put in a separate module, you can just restructure your code a little bit to accommodate the need. You don't need to introduce a bunch of protocols and a bunch of problems up front.
I think that's very good advice. Yeah. And it's hard to do as well.
What we could do here in Swift is to use extensions. For example, we can have a generic method execute request. They can execute any type of request, URL requests. And then every module has its own API client extension with whatever method they need. So let's say we are breaking this now in modules. So this is the API module. We don't need this mock anymore. Then we have the logging module, for example. And we have the feed module. And what if we had like a generic function here, execute, and then it has a completion. Let's say it just completes with data for now. We're not handling errors.
Right.
So this API is enough to execute any GET or POST request, for example. Maybe not enough for uploads and downloads, but we don't have this requirement yet. And then what we can do is move the logging function to the logging module by introducing an extension in a separate module to the API client with the logging implementation. We can even move the logged in user struct to that module as well.
Yeah, that makes sense.
And we can do the same thing for the feed module. We have an extension in the API client that is the load feed. And the load feed and the logging method will call the execute, the generic method. And then we can move the feed item to the feed module as well. And now we have this implementation where we specialize the client for the module. And we have a generic client in the middle, which even can make this whole API client thing redundant. We could have just used plain URL sessions by creating extensions on URL session or Alamofire or whatever you use. But if you want to create a nice facade for your networking layer, you can use this. And look how we broke the dependencies without breaking the implementation. We just restructured, changed a little bit the architecture, the dependency graph. But look how the API client is still shared between all those modules. So if at some point you need to add a new module where you want to upload data to the API, you might have to add a new method here and you break the clients as well. You're not completely safe from change, but it's much more flexible now. Now, this is stage 1. What if you need a little bit more flexibility and not breaking the clients? We make this more reusable. Now we talk about inverting the dependency. What if instead of the modules depending on a concrete API client, we actually make the concrete API client depend on the modules?
Right. That's the second stage. And this is going to give us all the freedom that we want, basically, once we do it.
Exactly. And most applications I've seen, 99% of the applications I've seen, stop here.
Right.
And eventually, when this gets too messy, the solution is to rewrite the application. Because that's what's going to happen if you don't proactively understand where your architecture is moving to and change it as needed. You don't need to start with a super abstract implementation. You can move little by little.
Yeah.
But you need to move and you need to be proactive and you need to make those decisions as you go. And at some point, you might need to invert dependency because the API client is just a detail. What is important to the business is not the API client implementation and API requests. If you go to your boss and say, oh, we're having a problem with the request, they don't care, right? They care about the features. They don't care about the technicalities and the details. That's why I prefer to have contained logic in modules and details depend on the features. In this case, the detail is the API client. Now this starts opening up a bunch of options here. And to do so, we introduce protocol or closures or any type of interface for the modules. For example, the login, it needs a function or it needs a type that implements a function by talking to an API. The feed will need a function to load the feed. The followers will need a function to load the followers. And that's all they need. It doesn't need to know where it comes from. So when you have a concrete type dependency, as we have here, when the login module directly references the API client, we depend on the API client. We need to know how to locate the instance in the shared pointer. And then we need to invoke the function we want. When all we want is a function, so why don't we just depend on a function or on a protocol that implements the function? And now people start getting scary because, okay, this is not familiar. This looks weird.
Right. So I think you make some very good points here. First of all, it doesn't look familiar because there is this specialization that you mentioned before. So now what you're doing there basically is for the logging module, I need something to log me in and I don't care about anything else. So the ease of use we talked before by exposing a shared instance of this API client and being able to use it anywhere without any constraints. Well, that doesn't specialize thing because all modules have access to everything else. However, what do I need as a login module, as a feed module, as a followers module? What do I need? You need discipline to ask yourself that, and you need to continue to answer this question and move on and actually implement that thing. That's why I think we don't see it often, and we hear so often about the rewrites for the features or the whole code bases.
Yes. And there's also good arguments against it because they say the API client should be very generic. It just make API requests, right? This API client can be a URL session, can be a Alamo Fire, or it can be your own facade. And you're just saying, this is the most generic thing. You just execute requests. And you say, okay, you can still keep this whole separation. You can go level 4.
Right. Yeah.
And level 4 is you have your generic API client in the center. You have your modules with only what they need. And then you implement the adapters, probably in your main module, but it doesn't have to be. You can have your adapter module. You can have whatever you need. But now you start separating all the modules. Now, this is completely modular because you can use this API client in other applications. You can use the login in other applications, in other contexts. You can use the followers module in other contexts as well. You can just compose all those things together. And when you're testing, you compose it with mocks, or you compose it with stubs. You compose it with whatever you need.
Absolutely.
You open up possibilities. Level 4.
Yeah, as I mentioned before, freedom. And the bigger the code base and the more complex it is, the more complex the requirements are, I think freedom is a tremendous asset to have. On the other hand, it doesn't come easily. You need to be very disciplined to reach that stage. And as we mentioned before, if you're making a small application, and you should definitely not start with the level 4. By the way, these levels for the audience out there, we just mentioned them as a way to keep count for the slides, right?
Yes, it's not a thing.
No, it's not a thing. It's a level of abstraction based on the slides that we have there.
But, okay, you're saying this is not easy, and I agree, this is not easy, but I think this is simple.
It is simple.
In the grand scheme of things, it means that you can compose those things simply, you can change things simply, you can test things simply, and to be fair, people look at this diagram and they compare with the first one we showed, and they're like, this is over-engineered. Look how many things. But the diagram doesn't tell the truth.
Exactly. It's not over-engineered.
The architecture is in the code. So let's show the code that implements exactly that. We still have the dependency on the API client, but all we need is a logging function. And the logging function is this. So all we need here is a logging function that gets a callback. Let's make this optional for now. It needs to be injected. Of course, this is a closure. It's a closure where you invoke with a closure callback, something like that.
Right.
And now you can move the API client to a main module. Great. Now the feed. All you need is a function or a protocol with that function. So we have a load feed function where you pass a closure. And now you move the load feed to the main module. And now the main module just needs to compose the functions by passing it to the modules.
Right. And not just these functions. The main module can compose any functions. Right. So this is very important as well here, because we just abstracted the API, the remote part for these actions, logging and load feed. However, these are just signatures of these functions, right? Meaning that you can have a remote or a cast version, for example.
Yeah, you're free to do whatever you want, very simply. And you have the same amount of code.
Yeah, absolutely. Absolutely.
So maybe you look at this diagram and you feel intimidated, but it's just because you cannot translate diagrams, concepts, modularity into code. Sometimes it's not as difficult as we think it is.
Yeah, certainly not. It just takes some time to fiddle around with these things and get it working. Definitely, in my opinion, test driving these things and working with protocols or closures for dependency injection, I think that's a great way to become better, improve.
So now, how would you test this? How easy would it be to just inject a function and expect something to happen?
Right, that's it, yeah.
In the feed view controller, how easy would it be?
Yeah.
And it doesn't need to be a view controller, of course. You could be using a view model in here.
Right, this can be anything, right? A view model.
And then you have like a load function.
Yeah.
It can be
a service.
A service. Exactly. It can be other things. It doesn't need to be a view controller. Let's say it's a feed module. Somewhere you need to load this data and it needs to talk to an API. But it's not your concern where this API is, how to locate it in memory, what kind of implementation, what kind of concrete type I need to talk to. And then from all the methods it implements, which one should I call? You don't need to be concerned about that.
I think the word concern is extremely important here that you mentioned, because that's what we're doing here. We're doing separation of concerns, basically. And each component, like this service or this view controller before, they were just concerned about themselves. They were not trying to fit everything in, nor have access to everything. That's very, very important right there.
And then we can even start having better type safety and enforce with an initializer. And then you're free to have any implementation you want. And it's completely separated from API requests. But now, how would you test the API client? First of all, I think that at this point, maybe this facade is not even necessary. But if you still need it and you want to test it, one way of testing this is to actually make the API requests by invoking load feed and invoking login and having an end-to-end test if you need to guarantee your API is returning exactly what you need. But now this is flaky, because how can you run this test if you don't have internet connection, for example? So what you can do is then you can use some libraries like HTTP stubs, where you can stub URL sessions and return hard-coded JSON and just check that you are mapping the data correctly to whatever type you want. And then you can use decodable. That is going to make this work much easier as well. And I would even encourage you to have at least a little bit of end-to-end tests, especially if you're talking to an API that you don't trust. Maybe they change the protocols without notifying you. It's always nice to have some smoke tests in a separate target that you run occasionally on your CI or before releasing an app, just to catch errors with integrating with a real API. But all this code here can be tested without actually talking to a real API. Now, the way you're going to implement this API client, if you have this separation here, I don't care. It can be a singleton, it can be global state, it can be a capital S singleton, a lowercase singleton, it can be URL session, it can be AF network, I don't care. As long as my modules are abstracted from that and I'm able to easily replace it, I'm able to easily compose those types together, I don't care about the API client. I have my preferences, how I would implement this, but then this is a personal preference. All I advise people to do is to go to step 1, 2, 3, 4, or maybe 5, 6 when needed. Just understand how you can go from one step to the other. Understand the limitations of singletons with capital S, with lowercase s, and make the choices for your current problem. You can make singletons testable, and you can make lowercase singletons testable as well by property injection, if you allow subclasses, for example. And then you can just transform your singleton into a global mutable state and replace it in tests. That's another approach. I don't recommend it. Most of the times it's not going to pay off, but sometimes it pays off. So maybe you start there, but know that there might be a problem. And when the problem occurs, you know where to go to the next step, and then to the next step, and then to the next step. Your code should be soft. That's the essence of software. You should be able to make those decisions as you go. So don't limit your decisions with frameworks or design patterns. That's my advice here.
That's our advice in Essential Developer. Yeah, I totally agree with these things.
I don't know if I answered the question, and hopefully we did. But we should probably stop here. That's a lot to think about. I recommend you to take notes from this video and maybe ask more questions. Try it out yourself. Try to look at your code right now and draw some diagrams. Try to find some bottlenecks in there and let us know. Did we answer your question? Was that helpful?
Right. So yeah, practice is the number one thing. If you would like something like that to work, you need to spend some time testing out these things, trying new ideas, recognizing what you did wrong, in quotes, in previous projects. And then at some point it will click.
And some things that you did right in some projects is 100% wrong for other projects.
Absolutely. We should also mention here that if you abstract too early, you will find yourself trying to fill the gaps by hacking your way. And you don't want that, right? That's why we recommend do not abstract early. Just let it grow organically. Let it come when the time is right.
And it's very easy to have the wrong abstractions. As long as it's self-contained in its own module, the damage is also contained.
Yeah.
But when you have like this massive shared state in the middle where everyone talks to, if you have a mistake, the mistake is going to be huge.
Absolutely.
Cool. I think that's it.
Perfect.
Okay. We hope you enjoyed this video and learned something today. Don't forget to check the links in the description. Don't forget to subscribe, and I'll see you next time.
Thanks for watching. Bye, y'all.